Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions. Co-hosting with me today is David Charbonneau.
Hi, I'm David Charbonneau, and I'm excited to be the co-host for this episode of Open Source Directions. I lead the development of open teams here at Quansight, and I'm based in Durham, North Carolina.
And our guest today is Hamir Abbasi. Hamir?
Hi everyone, I'm the lead maintainer of PyDataSparse and I'm also a scientific software developer at Quansight. I'm based out of Frankfurt, Germany.
Excellent. Thanks, Hamir. So before we get into PyDataSparse and the roadmap and all of those fun things, we like to do a little personalization section at the front. So here today, we've chosen to present you with some open source headlines from the past couple of weeks. So Hamir, I believe you have a headline you'd like to share with everybody?
Yeah. So I was surprised that to hear about last week that Microsoft is making Chromium the default browser engine for Microsoft Edge. And I really like what they're doing with their open source community and how they're giving back eventually.
That's cool. That's a great piece of news. That's very cool to hear. Let's see. My news story this week is that Python has a new governance model. PEP 8016 was approved and selected. That proposed the steering council model as Python's new governance model. I'll post a link into the chat in a moment, but that's pretty exciting. If you recall, a couple months ago, benevolent dictator for life, or former BDFL, Guido van Rossum said he was going to step down, and they needed a new model, and so now we have one.
Excellent. Thanks, David. Yeah, thanks for bringing that up. For my headline this week, PyCon Columbia has announced that their keynote speaker is Carol Willing, a longtime contributor to the Jupyter project and one of my personal open source heroes. So congratulations to Carol, and if you happen to be in Bogota in February, you should definitely go. At this point, we're going to go ahead and introduce PyDataSparse for those of you who may not be familiar with it. Just very briefly, PyDataSparse is a project that aims to provide an ndarray compatible container for storing sparse arrays and implements the NumPy API, NumPy methods that act on those containers. At this point in time, PyDataSparse has about 169 stars on GitHub and about 5,000 downloads on CondaForge or via Conda. So with that, we're going to go ahead and ask you some questions, Hamir. So David, you want to go ahead and take the first question?
Yeah, Hamir, why was the project started?
So I'm not sure, actually. Matt Rockland started it in his off time at Anaconda. And, well, I got into it because of a certain tensor factorization, actually. And I saw that there was an easy way to do multidimensional sparse arrays in MATLAB, but not in Python. So I looked around, found this project to be the most promising, and just took it up.
Very cool.
Yeah, excellent. So what need does PyDataSparse fill? Certainly some sparse factorizations that you just mentioned, but what other roles? What else can PyDataSparse do for you?
Okay, so currently in the PyData ecosystem, there is not much of sparse containers available. The most feature complete one is definitely scipy.sparse, but it has the limitation that it goes with the numpy.matrix interface instead of the numpy.ndarray interface. And there's also PySparse, which is a different project. So both of these only support two-dimensional containers, and they don't comply with the ndarray API. So the thing that we offer out of the box is that we are compatible with ndarray.
Excellent. And I believe this was mentioned last episode even as well, that numpy matrix container is due to be deprecated, I believe, correct? And so
correct. There is a plan to deprecate it, and currently its biggest user or its only important user is scipy.sparse that there is no alternative for at this point. And I hope to make PyDataSparse that alternative and eventually get rid of numpy.matrix.
Excellent.
So I think you might have answered this earlier, but beyond PySparse and I think you mentioned another one that's in NumPy. Are there other alternative projects that you know of that are out there?
Not in the Python ecosystem, no. In other languages, there is suitsparse for C++. There's LAPACK, BLAS, Atlas libraries, and NMKL libraries for C and so on. But in Python, PySparse and scipy.sparse are the only ones I know of.
So what technology is PyDataSparse built upon?
PyDataSparse is built on top of NumPy and Numba. And we use NumPy for things where we feel it's appropriate, but where that would be too slow, we use Numba. And until recently, we also relied a bit on scipy, but scipy is now it's still a dependency, but none of our major algorithms actually depend on it at this point.
I see. And the Numba dependency, do users have to know how to use Numba at all, or is it totally under the hood?
It's totally under the hood. So we just use Numba as a sort of a low-level thing. It's similar to how NumPy uses Cython, or how any other library would wrap low-level libraries, but you don't really need to know how to use Numba at all in order to use scipy.sparse.
Excellent.
Earlier, you mentioned that Matt Rocklin had started this project. Were there any other folks that were involved in getting it going?
Ralph Gomersov has made quite a few contributions as to ideas and what to do. Matt Rocklin has made code contributions earlier on in the project. There's Stephen Hoyer, who's also contributed to architectural decisions on this project. There are a few off and on contributors. Alex Williams, someone from China that doesn't seem to have a name on GitHub. And there are some off and on contributors, but I'm the main developer at this point.
So who maintains the project? Is it you, or are there other folks involved?
I'm the lead maintainer at this point, but I suppose you could think of other people who contribute as they're not really maintainers, but they do contribute quite a bit, and this project wouldn't be where it was without them.
Great, excellent.
You mentioned a few contributors. Do you know what development communities or technical communities those contributors and users are coming from for PyDataSparse?
So if we look at the stars on GitHub, most people seem to be from academic institutions in one place or another. And recently, about 2 weeks or 1 week ago, we got our first major library integration into TensorFlow. So those are the main users of scipy.sparse at this point.
Is PyDataSparse participating in any diversity and inclusion efforts at all?
At this point, no. The project is too small to have a formal governance structure and so on. So it's definitely way too small for that. But yeah, anyone's welcome to contribute, use, or otherwise help out.
Excellent. So sounds like you're trying to be inclusive as much as possible, even though the project is small. Well, thanks, Samir. So at this point, we're going to do a project demo, one of my favorite parts of the webinars here. So I believe you have some notebooks and things to walk us through what PyDataSparse is and how it works, correct?
Yes, I do. I'll just share my screen in just a minute.
Yeah. Oh, and we forgot to kill the title screen.
Okay.
A little more engaging now.
Yeah, there is my screen, and we get the Okay, so here's a notebook that shows how to use PyDataSparse. So, for example, this line you would have to run if, for example, you were running trying to install it from master. But we're just going to skip that now since I already have that installed. So first we go ahead and import our, and let me go ahead and make this bigger. So first we just import numpy and sparse, and then as an example, let's build an identity matrix, sparse identity matrix. So here we can see that that this matrix has a huge size, about 10 to the 14 elements, and we can see that the fill value is 0.0. What we can also do is if we add another another point here, we can see how big this matrix is. So if we have x.n bytes over 1, 10, 9 to the 9th, and here you can see that it's only 0.24 gigabytes, and a real dense array would be quite a lot bigger. So we can also create a random array in PyDataSparse. So if we run this, it's going to create a 10 to the 7, 10 to the 7 random array. And
So what does that density mean in the random array? Could you explain that?
Yes, so density basically means the amount of elements that are actually stored compared to the amounts of elements there are in the entire array. And here we get our random array. Great. We have another data structure in PyDataSparse besides COO at this point, which is DOK. And we can create it exactly as we would an numpy array, and we can, for example, assign some elements to it. So if we do this, whoops, it seems I seem to have gotten a memory error.
Well, you put too dense there, right? So that's probably why you...
So if we just erase this part. Oh, sorry. So I need z.toDense. And if we do this, we can see that the reverse diagonal elements have been set to 1 in this example. And then we can do anything with sparse arrays. We can add them just like NumPy, and this will take a bit of time since it's 1 million elements that we are adding. And yeah, here we get our, and we can check where the dense elements are equal to the original elements, so we can also do that. And
So this is just doing a normal comparison operation?
Exactly, it's just doing a normal comparison operation between these two arrays. And here we can see that the fill value has changed to true. So normally with sparse arrays, you have a fill value that's false or 0, which means that the thing that you're not storing per se is 0. But here you can have it different. So in this case, the fill value is true, which means that you're not storing the true values, and you're storing the false values.
Right, and its D type is bool, like you would expect for any result of a NumPy comparison operation.
Exactly.
Yeah.
Exactly. This uses the same NumPy ufunc machinery under the hood to do its calculations. So it has exactly the same semantics as a NumPy array normally would.
Awesome. That's great.
And here we can see that we're adding 5 to a NumPy to our COR array, and this thing has a fill value of 5.0. So normally you would expect this to densify, but for a fill value of 5, it can also add 5 to a 0 fill value array and have an array that has a fill value of 5, as you can see here. And so for example, let's do a smaller example. So if we do this, we get this sparse.i5, so an identity matrix of 5 plus 5.toDense, and we can see that it converts correctly to a dense NumPy array. And we can also do, for example, we can apply NumPy universal functions directly to a sparse array. So as you can see, this calculated the exponential of that sparse array we had up there. Its fill value is 1, because if you feed 1 into an exponential, 0 into an exponential, you get a 1. And we can calculate the sum along any axis.
Just a quick question. Is this using, in the exponentiation, is that using a particular sparse algorithm to do the exponentiation, or is it using just the normal Python? Or I guess that's not xboom, right? So it's not.
So there are two parts to calculating a sparse array, right? You have to calculate which coordinates are non-zero, and you have to calculate the values at those coordinates. So for calculating which coordinates are non-zero, it uses the old. It uses the same old procedure of matching which coordinates are non-zero and so on. And for calculating the actual values, it uses the NumPy's own exponential universal function.
I see. Okay.
And here we can do indexing on the sparse array. So here we are getting the 5th row and the 4th to 6th column. And we can see that we get this array. We can also stack arrays, and we can get this stacked array. We can multiply, matrix multiply arrays with the dot. And here we get another. And we can also, this is a recently new feature that we added, that you can multiply dense arrays with sparse arrays to get back a sparse array. And this is useful in many situations. So for example, you have a very small sparse array, but a very big, very small dense array, but a very big sparse array, and you want to multiply them. This will do that for you without repeating anything. And
excellent.
And here we can see that we get exactly 2 non-zeros as there were in the original dense array. And but if we try to add them, you could see that this would actually be a dense array. So here we get an error value telling us that we can't do that, basically. And that's it for my demo, I guess.
Excellent. David, did you have any questions before we move on here?
I didn't, but there had been a question in the chat, and I just want to mention it and confirm the answer I gave, which was that in that example where you created the Boolean sparse array by comparing the two arrays, the fill value was true. And that means that true wasn't stored, only the false values for the sparse array. Is that correct?
That is correct, yes. So basically what we do is we cut out the sparse value, and we only store the places where the value would not be equal to the fill value that you have there.
Got it.
Perfect. Excellent. So at this point, we're going to go ahead and jump into the roadmap discussion for sparse, which is sort of the meat of the episode. So here, we just put out the roadmap. Actually, I think it got up today or tomorrow on quansight.com/projects, or today or yesterday, sorry. And I know, Hamir, you've been working on the PyData roadmap yourself for a while now, at least a couple months here. And so we're going to go through and prompt you with some of the roadmap items, and we'll have a little discussion, and you can feel free to dive into as much detail here. And the important thing to remember is these roadmap items are places where PyDataSparse is looking for contributions or help, either in terms of funding or monetary contributions to help fund these efforts, or perhaps contributions in code itself, right? So these are either places kind of you as an individual or an organization can get involved. And yeah, with that, why don't we take it away, David? You want to go ahead and take the first roadmap item?
So Hamir, one of the items on the roadmap is support for more storage formats, with the most important being CSF, which is I guess it says a generalization of CSR and CSC. Would you like to describe that a little bit more?
Sure. So scipy has these formats called compressed sparse column and compressed sparse row formats. And the good thing about these formats is they take up less space than COO under most situations. Not all situations, definitely, but under most situations. We're hoping to add a generalization of this called the compressed sparse fiber CSF to PyDataSparse. More than just the memory characterization of these formats, there is the important thing that CSR and CSF, or CSR and CSC, excuse me, can be passed into and out of many already existing libraries to perform some kind of operation. And the problem that we have there is that for currently we would have to use scipy's machinery to convert into CSR or CSC and then pass them in. And this is undesirable since we're trying to get rid of scipy.sparse at some point. But if we have this format, that would allow us to have zero overhead passing into these libraries and getting data out of these libraries, which is in itself much more important than the memory characterization. It would be a catalysis to adding more functionality in.
Right. So it would be fair to say you might need this capability to interact with things like BLAS and LPAC and take advantage of their acceleration routines. Is that sort of the idea here?
That is the main idea, yes.
Okay. Now, has anyone, I'm curious, is there prior art in sort of a CSF? Has anyone described that and you're just wanting to implement it, or do you have to come up with the format yourself?
There was a researcher at, I think, the University of Minnesota called Shaden Smith.
Mm-hmm.
He's also spending a little time on this project. He came up with this format called CSF.
I see. Okay.
Yeah.
Excellent. Well, hopefully we can link to that in the show notes and get a better description of it. So, and again, yeah, anyone who wants to jump in and help with that effort is most welcome to. So the next roadmap item is better performance / algorithms. Can you give a couple of examples there and in terms of where you think performance can be improved and what algorithms specifically you might be looking at?
Okay, so for example, to put COO in the order that most algorithms expect, we have to sort the coordinates to be kind of C-contiguous, the way there would be in a C-contiguous array in NumPy. And currently we're using a quicksort to do that, which is in NumPy. And I'm hoping to get a radix sort into NumPy so that we have order of n sorts instead of order of n log n sorts. And this would already speed up a lot of the algorithms in PyDataSparse by maybe a 2.5 times factor.
Wow.
And another example is the fact that we loop what we do currently in our element-wise calculations, and this is a really bad way to do it. But I couldn't at the time that this was written, there was no dependency on numbers, so you couldn't get down to the lower level algorithms at this point. But what we do is we match every single possibility. So if you have 3 inputs into a universal function, we check whether each of these universal functions is not 0 or 0, and then there are 8 combinations of that. And this takes a long time. So if we got it into a way where you could loop through the coordinates once and just check the zeroness or non-zeroness of everything once, then that would be quite a bit faster.
There's some really great examples. So would that at least for the first radix sort issue, that would involve improvements to NumPy even, right? So that's you're kind of, is that true? So you'd also be looking at extending things in other parts of the PyData ecosystem?
Yes, the radix sort. I actually opened a PR yesterday into NumPy. It isn't complete,
Ah,
but yes, I opened a PR into NumPy about yesterday or day before yesterday that would add this functionality to NumPy, and it would. And there was actually interest from Czar as well on having a radix sort in NumPy.
yeah. So for folks that don't know, that's the compressed in memory compressed array project, right? Um, so yeah, it seems like one of the design goals of PyDataSparse might be to be as small as possible, and then have the supporting libraries have as much of the underlying capability as possible as well, right? So
Yes.
yeah, excellent. Okay,
Another, I was going to say
that's it,
that,
Dave.
yeah, and
Yeah.
oh, we're done? Or
No, go
oh,
for it, David.
sorry about that. I got a little confused. And another item you have in the roadmap is covering more of the NumPy API. Are there specific parts of the API that you're looking to address first, or could you go into a bit more detail?
Okay, so there are quite a few parts of the API that I actually want to address. The most important is blast support. I would like to have that. And another point on this item is not necessarily adding more functionality, but making it easier to access that functionality. So, for example, right now, if you do something like numpy dot and pass in two sparse arrays, that will not work currently. It would try to make the numpy convert the sparse array into a numpy array, and that doesn't do the right thing. So with this protocol called the array function protocol, that's making it into NumPy 1.16 in draft form and probably 1.17 in uh, in a final form, we will be able to do the something like numpy dot and pass into sparse arrays, and that will automatically call the right implementation for that. And but this will mean for the end user is they don't have to care whether what they're passing in is a sparse array or a dense array. It will do the right thing most of the time.
That's fantastic. Yeah, that sounds
Excellent.
very, very helpful.
Yeah, I think that's kind of a common theme, in fact, on the show, is that we see a lot of projects wanting to cover more and more of the NumPy API, even though NumPy is not really a standard in the truest sense of the word. It's kind of a functional standard for a lot of folks. So, leading on from NumPy, the next roadmap item is about scipy integration. So we had Ralph on a couple episodes ago. And he mentioned PyDataSparse, so maybe you could take that in a little more detail.
So the most important point here is that scipy's current lineage routines in the sparse submodule, and also their CS graph submodule, it uses scipy.sparse internally. And like I said, numpy.matrix is trying to get rid of. Scipy.sparse is a blocker to that. And so what I'm hoping to do is make scipy.sparse work with these PyDataSparse would work with these subroutines, so that you don't have to care whether it's a scipy sparse array being passed in or PyDataSparse array being passed in. They'll just like work on and do the right thing. So this is more in the vein of replacing the scipy.sparse internally within scipy.
Very cool.
Yeah. Awesome. That sounds really cool. So that additionally sounds like another great place where people could jump in and contribute either code to making that work and or funding to help support someone to make that work. Having been in the scipy.sparse module myself in a past life, I know that there's a lot of work there to be done to make all that integration actually connect and work properly and test properly and all that fun stuff. So
The
David,
next item on the roadmap is Dask integration for high scalability. Would you like to describe that a bit more?
So So since this project was started by Matt Rockland, and he was the mind behind Dask, so to say, it already has a bit of Dask integration. So you can already use Sparse and Dask together to build to use sparse arrays across clusters. And but the bad thing about this is that that isn't as complete as I would like it to be. And so one thing that would help is bringing more and more sparse array features to Dask, so that you can have you can take your sparse arrays, which allow you to work on big data, and take them to clusters, which allow you to work on even bigger data and do something like, I don't know, natural language processing that uses these kind of huge data sets.
Yeah, very
Sounds
cool.
really, really powerful. Yeah.
Especially if that's your problem is a big sparse word set. So similarly with other integration, you've mentioned coop integration and GPU acceleration. So do you want to describe that? I imagine it has sort of a similar bent here to some of your other integration efforts.
So one thing I hope to be able to do is make sparse arrays faster, right? Speaking generally.
Sure.
And so QPy could help with that. It could make sparse arrays definitely go faster. There are already routines in CUDA for sparse blasts. So, and I think QPy already could wrap those maybe, or we could work with QPy to wrap those. Or there's also things like, but the big blocker to that is that we're using Numba under the hood to perform some of the calculations, and Numba doesn't yet work with QPy. So
I see.
So there's a lot of work to be done there, maybe re-architecting some of the things, but it's definitely something I would like to have.
Yeah, that sounds super powerful, and really another place where funding would be really helpful.
Another item on the roadmap is maintenance and general improvements. Are there any things that immediately pop to mind as particularly important that could use some extra attention?
So one of the things I was thinking of was rehauling the test infrastructure. So like I said, we're trying to add more and more formats to PyDataSparse. And it would be, I want to rehaul the test infrastructure so that every test is performed for every single format that we have, and probably even a combination of them. And ensuring that the correct thing goes in and the correct thing comes out, and there's no densification happening anywhere, is pretty important to this.
Yeah, got to avoid that accidental densification. So at this point, we're sort of at the end of the roadmap list, top level bullet points, but is there anything else you'd like to add to this discussion, Hamir?
So I just wanted to kind of tell people that I released Sparse 6.0, so 0.6.0 this morning actually. So if you want to try out PyDataSparse, go ahead.
Congrats! Yeah, excellent.
Congratulations.
Looking forward to trying that out. So just to reemphasize it once again, these roadmap items are places where PyDataSparse is looking particularly for contributions either in code or in funding. And at this point, we're going to go ahead and move on towards our Q&A section. A couple of questions have come in during the webinar already. And if you're interested, or if you have other questions, please go ahead and feel free to ask them in the chat or in the question window right now. And David, do you want to go ahead and pose our first question here?
Sure. Piero Peterson asks, does sparse support solving AX equals B, where A is a sparse array?
Okay, so the equivalent of numpy.solve, essentially. So currently, no. That is something we would like to have, but after discussions, we've kind of decided that this is the kind of functionality that should go into scipy rather than PyDataSparse. We put basic algorithms in in PyDataSparse, and the lineage, BLAS, graph theoretic, or other algorithms will go hopefully go in scipy. So
the more complex.
Go ahead.
Go ahead, David. Sorry.
I was going to ask, is there any planning around that currently, or do you know of any activity to get those algorithms into scipy?
The biggest blocker to getting these things into scipy is having the CSF format be completed. Yes, that's one thing we could usually use help with.
Yeah, the all-important CSF format. So.
Yeah, that's why I put it at the top.
Ralph Gomers asks, a past guest, as I mentioned before, on our SciPy episode, how are you feeling about the dependency on Numba now, after 6 months or more, perhaps, of experience with Numba?
I would say that it's not been too hard to work with compared to Python. So there are different things to consider, right? Right now we have in Python what is called a no-arch package, which means that we have just one tarball for all architectures, and it works out of the box, and Numba allows us to have that. If we had something else to do, we would have to build wheels for every single architecture, and probably a lot of different NumPy versions and so on. And that would complicate things quite a bit. Another thing to consider is that we're working within Python, and Numba is very easy to work with. So when I made the decision to depend on it, and Matt Rockland actually pushed that quite hard in the discussions, but I haven't regretted that decision. There were a few features that I needed in Numba, but the Numba devs have been quite good, and they added those in within a month or two. And after that, I haven't really felt the need. One thing we could use with Numba is more support for a JITted class object. So you could do some sort of object-oriented programming with that. Currently, you can only do functions of some sort. But once you pass data back to Python, it's no longer optimized, so to say. So these are some things just off the top of my head that would help.
Right. So Numba is kind of your way of avoiding a lot of packaging issues. It sounds like, at least in part, by getting some of the speed that you would get from something like Cython or
definitely. In my tests, in my early tests, it was even faster than Cython in most cases.
Interesting.
So, and it was easier to work with generally. So you don't have to learn another language. It's just a decorator.
Right.
And yeah, I haven't worked extensively with Cython, but this was definitely a lot easier to work with than my initial experience with Cython.
Oh, good to know. Well, thanks for answering those questions, Samir. I don't believe there are any further questions. So at this point, we're going to move on to our world-famous rant section, where we each get 15 seconds to rant about whatever topic we choose. Amir, it is your soapbox.
So I'm kind of pissed off at this point as how much access governments have to our private lives, and not just governments, even companies. So, and I would like to see that change one day, where we don't have what's called surveillance capitalism, so to say.
Good to, a salient point in our day and age.
Especially with the news yesterday that Netflix and Yandex and others had access to Facebook data, private messages and everything.
Crazy.
I think I may have ranted before about text spam. So this time I'm going to rant about reporting text spam. So the self companies often provide you some mechanism, like AT&T. You can text 7726 to report spam, and they'll ask you for the number that spammed you. But if they recognize that it's a text short code, they'll send you advice back, and that advice is text them back with the message stop. And typically any kind of spammer, you don't want to reply to them because then they know you're real. But in a moment of distraction and weakness yesterday, I texted someone stop back because AT&T told me to do it, and now I get variations on the same spam about every 2 hours since I texted them back. The worst part about this is that I knew it would happen, but I slipped up the first time, and now I'm stuck.
It sounds like a good reason to change your number, I guess.
Yeah.
Sounds like your two rants were related, in fact, in some ways.
Yeah.
For my part, I know that it's been said before, but certificate authorities seem like a dysfunctional mob, where these organizations extort protection money from storing a couple thousand bits. I know that other people are working on this, but I'm still perturbed by the whole certificate authority situation nonetheless. That's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including PyDataSparse, you can find all of the project roadmaps at quansight.com/projects. Hamir, where can people find you and PyDataSparse?
So you can find me on GitHub with the handle at Hamir Abbasi, just my name, and on Twitter with the same handle. And you can find PyDataSparse over at github.com/PyData/sparse or sparse.pydata.org if you want the docs.
Excellent. Well, thanks everybody, and join us again next episode for our scheduled discussion on Dask. All right. Thanks everybody. Bye-bye.